Hi there, Turgeon here, bringing you physics from afar. Let me help you with phase changes. We all know that things melt. We all know that things can freeze, boil, or condense. What most people don't understand is what's happening with the temperature, and most people don't understand necessarily what's happening with the energy and what's happening with the molecules. So here we see a block of a solid that is melting. What originally happens is there's almost like a preparation phase where you can see the temperature going up. Somebody's adding heat the whole time, adding heat, adding heat, adding heat to this little block sample. It's obviously a solid. We're reaching MP, which is the melting point, and now you see this thing starting to melt, and something curious happens, which is this thing is no longer increasing its temperature during that time interval. Watch this again. This is the key. This is one of the main important points here. So we are heating this object. It is no longer increasing its temperature once it hits the melting point. Now I'm saying heating the object. A lot of people interpret that as the temperature is increasing, or people interpret that as adding heat. I only mean adding heat. We are still adding heat, even though the temperature is not going up. Something else is going on here. Phase changes. Let's put the date. Something slash something slash something. The date right now for me is 5/9/22. It's probably going to be 5/10/22, but might do this year after year, so we'll see. Entry number there. So what I've taught you is that we draw motion of these molecules. We have a solid. We know that when something is a liquid, the molecules are moving faster. Notice I'm leaving no doubt. I'm not drawing arrows on every single one. And then the gas, there's no doubt here that this thing has gained a lot. These molecules have gained a lot of velocity. And if they gain velocity, they gain kinetic energy. By the way, remember when you're doing this that you are taking extra notes. Remember that you are unmuting, you are listening to the teacher, and also when you do a practice test on this stuff, you're going to want to use these notes to do the practice test. So make sure you unmute, make sure you listen, because that's where the knowledge is. The teacher is helping you. The teacher is teaching you. So you have to hear the words and have that like human experience, like the person teaching you something. Show this to your parents and guardians. They see, like, oh, my teacher is trying to teach me, not just telling me stuff, teaching stuff. There's a difference. Entry number. Okay, so this thing's, but something's happening here. And we want to know what's happening to the energy in those situations. So there's almost like a preparation phase. So before the phase change, which is also like a change in state, if you add thermal energy, that's just like adding something that starts with an H. Think about that. Then kinetic energy usually increases. That heat energy gives the molecules. You're seeing me pause for a second because I sort of think I meant to put something in. Oh, let me cross that out. I'm crossing that out. What I want to say is temperature. The temperature of the sample usually increases. So if we have Q, which is heat, measured in something, and we have T, which is temperature, capital T, not lowercase t. Lowercase t, no. We're not talking about lowercase t. We're talking about capital T. which is, you should write right here, you should write degrees Celsius. That's one of the ways I'll know you're listening. Degrees Celsius in joules, capital J, not lowercase j. What usually happens is, oh, the temperature just goes up. I mean, that's like no surprise. I mean, you heat something and the temperature goes up. The molecules are getting kinetic energy. That's nothing controversial there. No surprise. I've been teaching you that. But now we're saying something else happens during a phase change. This word is phase change. If you add thermal energy, which is known as heat, when the object is melting or the object is boiling. Now over here, I want you to put a note. It could go melting, but that could also be freezing. Freezing going the other way is melting. I want you to make another note over here. Boiling the other way is called condensation. I want you to make those notes there. That's how I'll know people are listening. The temperature stays constant. Wait a second. I'm saying on a graph of temperature measured in degrees Celsius, put degrees Celsius there. Q is heat, put joules there. I'm saying the graph is just horizontal. It just stays constant. Look at that. That's crazy. We're adding heat. Why? Because it's breaking bonds between molecules. And it's gaining another kind of energy. So let's draw this. So if we look at water, we're going to do a big graph. Really big graph, okay? And we're going to put 0 degrees Celsius. And we're going to put 100 degrees Celsius. And I want you to pay attention because we're going to really line up with that graph. What happens is, as you're heating the water, I'm going to draw this in dotted lines to kind of indicate this slow progress. You're heating up. And when I say heating up, I mean adding heat. This is Q. This is heat in joules. As you're heating up the water, the temperature goes up. No surprise. It's gaining kinetic energy. But then once it hits 0 degrees Celsius, this would be ice that's super, super cold, which happens all the time. Like the ice in your freezer is probably below freezing. Then something crazy happens. There's this period of time where you're still adding heat and the temperature is not even going up. I'm not kidding. It just stays constant. And then once it all melts, now you have only water, really cold water, the temperature does go up. Till you get to 100, now it's ready to boil, and now it levels off again. Now what can happen is, if you were to contain all that water, it would increase temperature again. Now let's label all this. This is increasing kinetic energy. This right here is actually melting. And that is increasing potential energy. Potential energy. So if we go back to the simulator, you can see that the objects are being torn apart. That brings them farther apart. And just like if you bring a rock farther away from the earth, right? Just like if I take my calculator and I bring my calculator farther away from the earth, I'm increasing the potential energy. Well, now we are increasing the potential energy of those particles right here. We are increasing right here. We are increasing the potential energy of these particles. We're pulling them farther apart. They're not gaining kinetic energy. They're gaining potential energy as they get farther apart. Then once they get to a certain point, they will start gaining kinetic energy. Once they are done with that phase, now they're going to start gaining kinetic energy again. They're not doing a great job of illustrating it until right about now in the simulator. So this is melting right here. That's melting. That's literally ice, but it's being converted over to water. And then when it's all water, it's, again, increasing kinetic energy again. Then this is boiling, which increases potential energy again. Then we have an increase in kinetic energy. That's this last part. This right here, this would all be ice. This stuff would all be water. And this stuff would all be steam. So if you were to somehow capture all that steam, you could increase the kinetic energy of the steam. So the big idea for this entire concept is that, and I want you to write all this, the temperature during a phase change, this is during a phase change, not like normal situations like when I heated up the metal ball. During a phase change, the temperature stays constant. That's here, and that's here. Notice, by the way, there are 5 segments. The molecules gain potential energy. Use that for your practice test and be ready for the real test. This has been Turgeon, bringing you physics from afar.